Good morning, students. Today we are going to learn about scattering losses. In the last class, we have seen different types of absorption and the causes for the absorption. In the last class, what we have studied is what is absorption. In absorption can be occurring in three different ways. One is due to atomic defects, intrinsic and extrinsic. So these are the three causes for absorption, and finally they come up with attenuation of the signal. Another type of attenuation we need to learn is scattering losses. These scattering losses also lead to attenuation. So in the today's class we will be learning what are the different types of scattering losses, and one more type of losses that are leading to attenuation are bending losses. So today we will finish bending losses even, right? I will start with the scattering losses and then bending losses. First we will discuss about scattering losses. Scattering losses generally occur when there is a refractive index variation in core region or glass material what we are using for the optical fiber. If there is a refractive index variation in the glass material what we are using for the optical fiber, then the scattering losses may occur. So what is the reason for this refractive index? The glass is a composition of complex molecule structures, and it is also a combination of oxides, that is SiO2, as you know, GeO2, P2O5, etc. Different types of oxides we will be taking for preparation of this glass material, that you already know what are these oxides we will be using. So as the glass is a combination of different complex molecule structures and the oxides, when during the manufacturing process of this glass material, if any microscopic variations exist in any of these two compositions, then they will be resulting into refractive index variations. Whenever the light that is traveling into the optical fiber is encountering this particular refractive index variation, immediately it starts getting scattering. The light path will get scattered, and this scattering phenomenon can be a linear scattering or non-linear scattering. The scattering phenomenon what we can see in an optical fiber can be a linear, or generally scattering phenomenon can be a linear or non-linear, and in the optical fibers we will mostly see linear type of scattering phenomenons. So what are the linear scattering phenomenon? Linear scattering is of two types. One is Rayleigh scattering, second one is Mie scattering. Most probably in the optical fibers, mostly we will see Rayleigh type of scattering, whereas Mie scattering is also observed in less amount. We will see now what is Rayleigh scattering and what is Mie scattering. Rayleigh scattering occurs due to microscopic variations in the composition of glass material. It occurs mainly due to compositional variations in the glass material. Whenever the light that is traveling inside the glass material is encountering such compositional variations, then immediately it starts moving its direction. Suppose here I am taking an optical fiber. This is your cladding part and here it is your core part. Let these be the molecules. Whenever each molecule is encountering Rayleigh scattering, immediately the light that is coming out from that particular molecule will be spreading out in this format. This is the Rayleigh scattering format which we generally observe in your sunlight. When the sunlight is reaching to the ground, it takes the same phenomenon, the scattering phenomenon what we see in the sunlight occurs here also. So this is your Rayleigh scattering phenomenon, and the Rayleigh scattering is given by 8 pi cube by lambda power 4 n square minus 1 whole square kb tf bt. The Rayleigh scattering, the amount of loss that can occur, that is your attenuation constant due to Rayleigh scattering, is given by 8 pi cube by lambda power 4 into n square minus 1 whole square into kb tf bt, where kb is your Boltzmann constant, kb is Boltzmann constant, tf is fictive temperature, lambda is wavelength, right? And this is beta T. Beta T is isothermal compressibility. Isothermal compressibility. So this is the equation that is governing the amount of attenuation that can occur in the scattering loss. So here one thing we have to observe, the amount of attenuation is inversely proportional to lambda power 4. So alpha is inversely proportional to lambda power 4. That implies that amount of loss is a function of lambda power of minus 4. So as the lambda increases, the amount of loss depend accordingly. Okay. Now the second one is Mie scattering. Mie scattering is basically due to structural inhomogeneities. This is due to the structural inhomogeneities, in the sense this structural inhomogeneities can be in the form of glass bubbles, density particles, etc. This is also one kind of linear scattering process. Generally, in an optical fiber, mostly this glass bubbles in the sense water molecules, these glass bubbles can be removed. We already know how to remove these OH minus ions in the glass that is fabricated, and it may also be the reason like unreacted particles. In forming the composition of different molecules, some unreacted particles may be left out in the glass material. Those will also cause the Mie scattering, and the loss and attenuation graph is in this manner. According as the wavelength is lambda power minus 4, and the relation shows a graph of this format for the scattering losses. The next type of losses which will lead to attenuation is bending losses, right? So these bending losses are of two types: macro bending losses, and the second type is micro bending losses. Micro bending losses. Now we will see how this macro bending and micro bending will be. Uh, so let this be the optical fiber core region. Here I am drawing only the core part. Inside the core, the electric field distribution of the core region will be of this format. So here the macro bending generally occurs in an optical fiber when the optical fiber has been bent for a longer curve. If a longer curves of bent of the optical fiber occurs, then the macro bending losses will be occurring. How this loss occurs is whenever the light that is traveling, the electric field of the light that is traveling inside the core region is encountering a large bend in its path, then the radiation will be slowly escaping into the cladding part, and at every point we can see some part of the radiation tends to escape into the cladding part, whereas if the bend is very large, what we know practically, listen, when we are traveling in a curved path, we can reach at a faster way. The speed of the light that is traveling at this curved region will be more than when it is traveling in a straight line. Basing on this principle, here the energy that is being distributed here at the curved path, it will be fastly moving, and most of the energy is lost here and it will be radiated outside. So this loss of energy at this macro bending level, that means larger bends in the optical fiber, is called as macro bending losses. Whereas coming to micro bending, this micro bending losses occurs in small variations in the structure of the core part of optical fiber. Whenever a small structural variations, if the core region of the optical fiber is having smaller micro bends in its structure, then the light that is traveling inside may get distracted and may get lost into the cladding region. So the light that is traveling here, you can see, is escaping into cladding region. In order to remove such things, the optical fiber core which is having micro bends is protected with a thick shield, so that these curves will be tightly held. By holding these curves in a very tight manner by the external plastic shield, what happens, whenever the light that is traveling inside the core region, when it encounters the smaller micro bends, it does not tend to escape into the cladding region. Because of this tight structure, it will start flowing inside the core region only. So because of this plastic shield that is kept on these micro bends, so that it will be holding those bends into a straight form, or it may hold that it may hold into a compressed form, so that it will not result into the escaping of the light. This is about macro bending losses and the micro bending losses. This is all about attenuation. So we have studied about attenuation and the three types of attenuation. One is absorption, scattering losses and bending losses. So another type of phenomenon that can occur in optical fibers which leads to loss of information or attenuation is dispersion. In our next class we will discuss what is dispersion and how it occurs and what are the different types of dispersion mechanisms. Thank you.